2.2 Polynomial functions of higher degree. A polynomial function is a function of the form f of x equals a sub n x of n all the way to a sub 0, where n is a non-negative integer and each a sub I is a real number. The polynomial function has a leading coefficient, a sub n, and a degree, n. So when we see n, it represents the degree. The degree is the highest exponent. And the leading coefficient is that number in front of the variable with the highest exponent. For example, if we have f of x equals negative 2x to the fifth plus 3x cubed minus 5x plus 1, our leading coefficient is negative 2 because it is attached to the variable with the highest exponent. The highest exponent is 5. Degree is the same thing as the highest exponent. Next, we have f of x equals x cubed plus 6x squared minus x plus 7. What is the leading coefficient? It is 1. This is considered to be a 1x cubed, so the degree is 3. And what about the leading coefficient of f of x equals 14? 14 must be the leading coefficient. And what is the degree? The degree is 0 because that's 14 times x to the 0 power. Anything to the 0 power we know to equal 1. So 14 times 1 is 14. 14 times x to the 0 is 14. Now, it could not have been x to the first power. Then you would have seen a variable next to 14. If n is even, their graphs resemble the graph of f of x equals x squared. Again, in this section, n represents the degree. So if the highest exponent is even, like the numbers 2, 4, 6, and so forth, then the graph will resemble x squared. What does that mean? It means that it will sort of be on the ends, so the end behavior will behave the same as x squared. So if the leading coefficient is positive, your left hand behavior will be going up and your right hand behavior will be going up as well. Now, if n is odd, again, n is referring to the degree. Odd numbers, for example, are to the third power, to the fifth power, to the seventh power. Then those graphs will resemble the graph of x cubed, meaning the n behavior will resemble the graph of x cubed. So, for example, on the right-hand side of x cubed, your right hand is going up or rising, whereas on the left-hand side, it's falling or going down. So any odd degree polynomials will act in this way. So the leading coefficient test tells us whether our n behaviors will flip or not, depending on whether the leading coefficient is negative, because we have learned in the past that if the leading coefficient is negative, then we will have a reflection. So, for example, if we have an odd degree polynomial, we said just a couple of minutes ago that our graph will resemble the graph of the cubic function, x cubed. However, if the leading coefficient is negative, notice that the left hand and right hand sides are flipped. So, whereas if the leading coefficient was positive, the right side is going up. But if the leading coefficient is negative, the right side is going down. And if the leading coefficient is positive, the left side is going down. Whereas if the leading coefficient is negative, the left side is going up. So it did it flipped or there was a reflection. So these dashed lines in the middle indicate that we don't know exactly what's going on the inside of the graph, but we do know the end behavior by determining the degree and the leading coefficient. Same thing goes with a even degree polynomial. Again, an even degree polynomial, the ends of the even degree polynomial will behave in the way the quadratic function behaves. If it's a positive leading coefficient, both left and right hand goes up or rises. But if you have an even degree polynomial and the leading coefficient is negative, both ends are falling. So again, this is also indicating that this is an even degree because both ends are going up, but we don't know what's going on the inside, but we know that this is an even degree. We also know this is the even degree because both ends are going down. So if on both sides your ends are going in the same direction, we know that our polynomial is an even degree polynomial. If both ends are going up, we know that the leading coefficient is positive. If both ends are going down, like over here, we know that our leading coefficient is negative. So let's try some examples. If we have f of x equals negative x cubed plus 4x, then is that an even or odd degree polynomial? Well, we see this is cubic, obviously, because it's to the third power, but it is negative, right? So since it is negative, our ends will flip. Our left-hand side will rise and our right-hand side will fall. So left-hand side rises. Right-hand side falls. Let's go to the next one. We have f of x equals x to the 4th minus 5x squared plus 4. The degree is 4, therefore it's even, so it will behave like the quadratic function. The leading coefficient is 1, so it's positive, so it will act like and I'll put a little dash in the middle, because again, the dashes represent the fact that we need to determine what's going on in the middle with some additional methods or tricks to figure out what's going on in the middle, but we do know the end behavior. So both ends rise in this case. And C, we have x to the 5th minus x. 5 is the degree. That is an odd degree polynomial, so it would act like the cubic function, and our leading coefficient is 1. Therefore, on the right side, we'll be rising, and on the left side, it will be falling. Left side falls, right side rises. So let me just make up a problem here to make sure you get it. What is the degree of this problem? The degree is 7. Why? That is the highest exponent. The degree is 7. What is the leading coefficient? As a result of that, the leading coefficient is going to be the number in front of that, which is -4. Since that is an odd degree polynomial, it will act like the cubic function, but it will flip, right, because of that negative leading coefficient. So for this problem, it'll be rising on the left and falling on the right. All right, let's figure out the inside, the middle of these graphs by finding the zeros of the functions. So for example, we have A, and when we say A, we're referring to the A we just discussed. How do you find zeros? We are going to set the function to 0 and solve for x. So here we will factor out a negative x. We have x squared minus 4 equals 0. That is a difference of squares. So negative x times x plus 2 times x minus 2. And we set all of these factors to 0. We have 3 different factors here. We set them all to 0 and solve for x. So here we will divide by negative 1 so that we get x by itself equals 0. Here we subtract 2, and here we add 2. So our zeros are 0, negative 2, and positive 2. Now, if I ask you to write out the x-intercepts, I would like you to write it like this: 0, 0, negative 2, 0, and positive 2, 0. Those are the x-intercepts. Now, that will give you what's going on the inside. So here's the graph. Notice that we have point on the x-axis at 0, 0, negative 2, 0, and 2, 0. We already knew that the left hand side was going to be rising and the right hand side was going to be falling because of that negative leading coefficient, which is a reflection. All right, let's move on to B, which is x to the 4th minus 5x squared plus 4. We're going to set that to 0. This is a trinomial, and the leading coefficient is 1, so we should just determine factors of C that add up to B. So let's split up that x to the 4th, x squared. Factors of 4 that add up to 5, negative 5, or negative 4, and negative 1, because negative 4 times negative 1 is positive 4. But when you add negative 4 plus a negative 1, you get negative 5. Here you see these are difference of squares. So we're going to break down these difference of squares. So now we have 4 different factors, and we're going to set each factor to 0. So the first one, we're going to subtract 2, we're going to add 2, we're going to subtract 1, and we're going to add 1. So our zeros are negative 2, positive 2, negative 1, positive 1. And again, if we had to write this out as x-intercepts, we'll write negative 2, 0, 2, 0, negative 1, 0, and 1, 0. Notice those points are here. So this would be our negative 2, 0. This would be our negative 1, 0. This would be our 1, 0, and this would be our 2, 0. Now notice again we have x to the 4th, so the ends will act like the quadratic function, meaning both ends will go up. Our leading coefficient is positive, so both ends will rise or go up. Now how do you find the y-intercept? The y-intercept, you'll plug in a 0 for x. So f of 0 equals 0 to the 4th minus 5 times 0 squared plus 4 will give you f of 0 equals 4. Our y-intercept written out is 0, 4. So that's that point right there. So you should be able to sketch polynomials fairly easily if you find out the x and y intercepts and you understand the degree in the leading coefficient test. All right, C, we have x to the 5th minus x equals 0. Here we have a GCF of x, so we're going to factor that out. So we have another factor of x to the 4th minus 1, which is a difference of squares. So we're going to break that down as x squared times x squared plus 1 minus 1. Now we're not done because this is also a difference of squares. So we break that down to x plus 1 and x minus 1. We set all of these factors to 0, x equals 0, or x squared plus 1 equals 0, or x plus 1 equals 0, or x minus 1 equals 0. So we have x equals 0. For this one, if we subtract 1, we get x squared equals negative 1. And square root both sides. The issue is this negative under the square root. So for this particular factor, we did not get any zeros out of here. So we're just going to leave that alone. That is not a real 0. And we haven't made it to the imaginary numbers section yet. So there are no real zeros in this part right here. However, we're going to subtract 1 over here and add 1. We will get x equals negative 1 and x equals positive 1. So for now, we do have 3 real zeros that you'll see on the graph. Here, that must be negative 1, 0, 0, 0 here, and positive 1, 0 here. And again, that's x to the 5th, so it definitely looks like the cubic function.